Welcome to Data Engineering with Subadip. Today, we are diving deep into query optimization case studies. Get ready to boost your data performance with real-world examples. First, let us understand what exactly query optimization is. It is the process of improving how a database query runs to use fewer resources. Our main goal is to get faster results and process more data efficiently. This involves smart techniques like using indexes, rewriting SQL, and leveraging advanced database features. It is absolutely critical for working with large datasets and complex analytical tasks. Let us dive into our first case study, sales aggregation. Our goal is to summarize total sales by product category and month from a very large transactions table. This table has about 100 million rows, with columns like transaction ID, product category ID, transaction date, and amount. Here is our naive query for sales aggregation. It groups by product category and the beginning of the month for the transaction date, then sums the amount. When we run this query on our 100 million row table, it takes approximately 45 seconds to execute. This is a lot of time and we can do better. For our first optimization, we introduce indexing. We will create a composite index on product category ID and transaction date, as these are the columns used in our group by and order by clauses. This helps the database quickly locate and sort the data. After creating the index and rerunning the query, our execution time drops significantly to about 8 seconds. This is a massive improvement. Our second optimization technique is partitioning. We can partition the transactions table by transaction date, for example, into monthly partitions. This way, if our query has a date filter, the database only scans the relevant partitions, avoiding a full table scan. If we now run a query that filters by a specific month, say January 2023, the execution time drops further to approximately 2 seconds, thanks to partition pruning. This is a powerful technique for time series data. For our second case study, we will tackle joins with large tables. Our objective is to retrieve customer names and their total order amounts by joining the customers and orders tables. The customers table has about 10 million rows, while the orders table contains around 50 million rows. This scenario is common in many data systems. Here is our naive join query. It performs an inner join between customers and orders tables on customer ID, then groups by customer name to sum the total spent. Running this query on our tables, which are quite large, takes about 1 minute and 30 seconds. This is a significant waiting time for an analytical query, indicating a need for optimization. For our first optimization, we focus on indexing join keys. While customer ID is already a primary key in the customers table and thus indexed, it is crucial to also index the foreign key customer ID in the larger orders table. This index significantly speeds up the join operation. After creating this index and rerunning our join query, the execution time drops dramatically to about 15 seconds. This demonstrates the power of proper indexing on join columns. Our second optimization technique involves using a subquery for pre-aggregation. Instead of joining two large tables and then aggregating, we first aggregate the orders table by customer ID in a subquery. This reduces the number of rows significantly before the main join operation, making the join much faster. With this optimized query, the execution time is further reduced to approximately 5 seconds. This approach is highly effective when dealing with aggregates on large tables before joining with dimension tables. Let us summarize our key takeaways. First, indexes are paramount. They are crucial for improving performance in where clauses, joins, group by, and order by operations. Second, partitioning is highly effective for large tables, especially with time series data and date-based filters. Third, consider query rewriting techniques, such as pre-aggregating data before joins to reduce the volume of data processed. Fourth, always understand execution plans. Analyzing them helps identify bottlenecks. Finally, remember to balance read and write performance, as some optimizations can impact write operations. Thank you for watching. I sincerely hope these query optimization techniques help you achieve blazing fast query performance in your data engineering endeavors. If you found this video helpful, please do not forget to like, comment, and subscribe to Data Engineering with Subadip for more content. Connect with me on social media as well. See you in the next video.